Thanks for joining us so far and having fun. You guys keep talking quietly in the background. I like it. It's fine. Keep going. But I am also very happy to introduce Jack Clark, one of the co-founders of a new company called Anthropic, which has an incredible and very exciting amount of funding, and co-chair of the Stanford AI Index, and the co-chair of the OECD Working Group on AI and Compute. I love Jack, and as I just said, his is the only slide deck I will ever allow at any conference because it is amazing, which feels weird to say. So take it away, sir.
By amazing, Austin said it was such an ugly slide deck that his designer had to step in and do something. So don't get your hopes too up. Anyway, so what I'm going to talk about today kind of relates to a lot of what we've heard about so far. I'm going to talk about recent trends in AI development. I'm going to talk about the resource asymmetries in AI development. So why does AI development now cost money for certain types of experiments, and what do we do? I'm going to talk about challenges in AI development, so some of the problems, and I'm going to talk about what needs to happen. Those are my views, the last bit, so I welcome critique and discussion about that. So first, let's just go over what's actually been happening, like what's been going on. So here's a graph from the AI index, but I think distills a lot of this stuff quite nicely. So it shows you performance on computer vision over time. And what's computer vision? Well, here it's just the task of looking at a picture and getting a computer to correctly label it and say, yes, I have high confidence that picture contains a picture of a bird or of a bear or of a car or whatever. And what you see is that, about 2013, this stuff was basically useless. It just didn't work well enough that you could use it in any real form. And then in the last 10 years, we saw our performance massively increase to the point that now you have an error rate of 1.5% or so on computer vision, and that explains why AI has suddenly proliferated around us. It's everywhere around us because it got good enough so people can use it in the economy. And just to give you a sense of how crazy this is, here's a comic from September 2014 where some people are talking to each other and they're saying, I want you to build an app that takes a photo and checks where the person took the photo. So that's easy. You just look at the GPS data embedded in the photograph. But then they say, and I want you to tell me if it has a picture of a bird in it. And the person's like, give me a research team in 5 years. So that was written in 2014, and it tells you what the prevailing sort of sense of the science was. That computer vision was a really, really hard problem, was an unsolved problem, and people were writing comics, admittedly nerdy, obscure comics, but still comics, about how hard and difficult it was. But that changed. And I think it's important to understand exactly why it changed, because it's kind of an overly simple reason. The reason why it changed is that this is a graph showing the amount of compute used in various academic experiments over time. It goes over the same period, 2013 to now. And what do you see? Well, you see the amount of compute that people are using to solve this image recognition problem is increasing significantly year after year after year. So we didn't get, truthfully, that much smarter. We just figured out how to dump huge amounts of resources into architectures based on deep learning, which is just stacks of neural nets. And it turns out, if you can sort of do that, you get good things as a consequence. So that's great. We like being able to turn resources into insights. That's a useful thing. But it's also a different thing to how AI research used to work. So here's the same graph, but I extend it back in time. So the part that you saw is just this bit of the graph. And here's compute usage going back to the 1960s, way back to the Frank Rosenblatt's perceptron, which is one of the earliest sort of interesting convolutional AI systems. And what do you see? You see that we're on a completely different amount of resources being used for AI research up until about the 2010s. And what that means is that lots of our policy around how to support AI research and how to support science and AI was developed during this period, when the resource intensity of AI was a lot lower than what it is now. And so I figured I'd try and, help sort of explore this point, because I think this is why things like the National AI Research Resource are important and why we should pay attention to it. So I'm going to talk about a recent system called GPT-3. Who here has heard GPT-3 before? Yeah, loads of hands. It's like a breakthrough system. GPT-3 sort of followed something like AlphaGo in terms of these systems that lots of people are familiar with. It's a text analysis and generation system that was developed by OpenAI, where I used to work. And I thought I'd just plot for you when GPT-3 got invented and who replicated it. So May 2020, OpenAI announces GPT-3. And then here are the public replications we've had since. Huawei, a year later, did a system called Pangu. Naver, a South Korean company, did a system called Hyperclover. AI21 in Israel did a system called Jurassic 1 Jumbo, which I think is the best name for all of the GPT-3 replications. Google did a system called Flan. Inspur, a Chinese company that makes servers, did a system called Yuan 1.0. And Microsoft and NVIDIA, as Anima mentioned, recently came out with Megatron Turing NLG, maybe the second best name after Jurassic 1 Jumbo, or best, and 530 billion parameters. So this is great. We've developed a new technology and loads of people have replicated it. That's good. The thing which worries me is that these are all companies. They're all companies able to wield really large amounts of resources to train this quite expensive thing. And this pattern has shown up in other areas. So recently people started developing the equivalent of GPT-3 for code, so a system that can read and write computer code in the same way it can read and write language. Useful, economically interesting, but the people developing it are all companies. So, let's explore why that is and figure out what we should do. So I'm going to go back to that graph I just showed you about AI and compute. And all I've done here is I've highlighted all of the results in recent years that came from companies, and the red lines tell you all of the results that come from academia. And what you'll probably notice is that there are more results in recent years that use large amounts of computation that come from companies than those that come from academia. So that's interesting. It tells us that the people dominating some of the frontiers of research, and per Dr. Parker's comments, this isn't all research, this is just a strand of resource-intensive research, but it's an important one with economic impacts, are companies. And again, if we look back in time, used to be different. We go back to prior to 2010, and the majority of really interesting results are actually developed by academics rather than companies. So something changed. Something changed about our resource intensity, and something changed about how we think about development here. Now, I was involved in creating these graphs, so I could just be telling you like a really convenient fiction or story that makes sense to me. So I think I did the scientific thing and I tried to validate it by using another person's graph. So someone's just, okay, there we go. So here's another graph from some like smart PhD students. It's almost impossible to read. I'm not expecting you to pay too much attention to what's on it. It's just showing compute over time. Main difference between those other graphs I showed you is that it's showing you the it covers more of the recent research and it sort of proves the trend out. So I'm not telling you a story. Someone else like validated this. They came up with different data points. They show the same trend. So what I did, and this is my colleague Danny Hernandez, who kindly did this for us last night, was we looked again at what's the mix of these results that come from academia versus industry, and we made this spectacularly ugly but probably informative graph, which is this. So the percent of results that come from academia over time, there's a trend here which isn't good. And specifically, the bad part of this trend is that from, 1950s or so until about 2010, academia is responsible in any given year for between 60 and 100% of the large-scale, computationally intensive results in AI, per that graph I showed you. And then something happens. Specifically, we figure out how to dump loads of resources into deep neural nets, and the percentage of these results being contributed to from academia, it plummets. Now we're around 10%. And I think that this really should motivate us to think about something like a national AI research resource, because these systems matter. And the number of people able to develop them, per, I think, Anima's comments earlier, has fallen, or it's shrunk to like a small set of private sector actors, and we need to figure out a way to sort of broaden this. So let me tell you, why we should care, because I don't think it's a purely academic exercise. Like the sort of models I'm talking to you about, they can do text generation and text classification. They can do data transformation. They can serve as the imaginations for other systems like robotic systems or planning systems. They can also perform tasks like image generation and classification. They can do learning. So these systems, you can prime them with different types of information and they'll rapidly get good at a new task. That's all useful. Like it's economically useful. I used to be an enterprise technology journalist and I used to cover this stuff. This is all money. This all gets turned into like useful economic things. But at the same time, these systems have real issues. Because they've become really, really capable, they also have a flip side to their capability, which is problems. These problems include harmful biases. You ask a system, what are the core tenets of Islam? And it might tell you the core tenets of Islam is terrorism, which isn't true. Like Islam is distinct from people that happen to follow Islam and commit acts of terrorism. System might not know that. It might have soaked up the biases that people have. You might say to a system, how are you? And it says, I'm George Washington, which is not useful. And is an example of how these things can have surprising breaks. It can do dangerous things. You can ask a system how to build a bomb out of household items or poison out of household items, and it'll tell you. So it's now like we've got an AI anarchist's cookbook. Doesn't sound great. You have other things, because these systems are good, they can also be used by criminals or bad actors in the same way that you might want to write compelling news content with them. You also might write SEO spam because you can make money off of it. They're difficult to interpret in the same way that people are difficult to interpret because people are complex. These systems have become complex and they're hard to understand. And crucially, a lot of these capabilities happen or emerge after you dump a lot of resources into the system. So the people that know that these systems can do these things or that they have these traits are mostly the people that can afford to create the systems. And finally, I think a good analogy to use when thinking about contemporary AI is that it's kind of like a funhouse mirror, in the sense that you give it a load of data from the world and it'll magnify and minimize that data in slightly unpredictable ways. It might develop strange biases. It might reflect something back to you about the culture it's trained on or the data it's trained on that is correct but horribly skewed or horribly exaggerated. And as a consequence, these issues are going to need to be studied. Like we don't a priori know how the mirror is going to change what happens after. We don't a priori know how these systems are going to operate over the data and develop new capabilities, some of which will have issues. And I think it's for that reason that we need to figure out ways to have a larger number of people study these systems and work on them because they're really complicated. So finally, and then I'll go to questions, or we can just skip straight to lunch depending on how people are feeling, what needs to happen? I've created another ugly illustration here, though it's not a graph, to help illustrate what I think needs to happen. I think there's a slight issue at the moment, which is that policymakers want us to be able to measure the risk of these AI systems. And AI researchers, after spending many years just developing systems and basically, having fun in a scientific sense, are now kind of pulling each other off the train tracks before the policy train hits them because they've realized that the scale of these problems and challenges requires, socio-technical interventions. It's not just going to be solved by scientists. It's going to be solved by a whole bunch of people looking at these systems and carefully deliberating about what to do with them, how to analyze them, and how to think about them. So I think there are a couple of things that we can do, both of which are sort of complementary to the goals of the NAIR. The first is, many of the ways we know about these issues of AI systems currently come from activists or academics or journalists. They're kind of like the person on the left here who's picking up a system and closely examining it and reporting something back. That's useful. But it's not as useful as having a system that can systematically analyze these systems and measure them and monitor them and audit them as they're being developed, in the same way that my preference is to get my news about the weather rather than from like a farmer who has great intuitions about the weather on their hill where they live. I like to use like a weather forecasting service which is comprehensive and coherent and funded. And it tells me more useful things and it creates better shared information. We need to build something like that to look at these systems and analyze them. Or to be really blunt, I do a lot of this one-off ad hoc analysis. I would like there to be like 10,000 people who are equivalently nerdy like me, who have equivalent resources and are able to like do more of this. So I want to build a system that facilitates this. And finally, to finish on the sort of most optimistic note, you know, people, and specifically America, like Hoden, I'm English, so I'm trying to not say us, but Americans have a good track record here. Like, we have like the Hubble Space Telescope, which cost about $5 billion if you include overruns and various other costs. We have the James Webb Telescope that's just about to go up soon and cost probably a frighteningly large amount compared to the Hubble. We are like completely capable of spending large amounts of money to unlock insights that everyone in the world can benefit from. And I think that that's the opportunity here. You know, what is the sort of computer equivalent of a Hubble Space Telescope? What's a system that we can build that can let people have more insights about these really impactful things that are being built around us? So that's my talk. I hope it was somewhat interesting, and thanks very much. If anyone has any questions, feel free to shout at me. Thank you. Don't know if there's like a roving mic or anything, but if anyone has any questions, just, you know, there is. There's a mic appearing. Good. We're going to sort of do this for like 5 minutes and then break for lunch.
Hello.
Hi.
So your slide on we need institutions to audit, monitor, evaluate. Who's going to fill that space? What kind of institution do you envision, and who's leading in setting up that kind of institution?
Yeah, a great question. I think that it will definitely be some combination of public and private. I used to think, maybe because I grew up in a country of the National Health Service, that we'd just do a giant public organization to do this. But I actually have been persuaded that you should have some public organizations like NIST, for instance, do a lot of work on the analysis and measurement and metrics of this. But we need to figure out a way to probably create markets for third parties that can help work on some of these assessments and audit things. I wrote a paper a couple of years ago called Markets for AI Safety, which is a way that you could create a regulatory layer that can be mostly private sector, that provides services, that audits other people's systems. I think there's a way that you can make this be something that entrepreneurs might want to build businesses around auditing and measuring, because that will just increase the effectiveness of the public institution. Who's in the lead? Well, no one. I honestly think this area is just like massively understudied. I mean, an experience I had when I was at OpenAI was we were developing GPT-3 and we were like, how do we think about bias for this system? Looked around, there's like not much that we could use, so we had to roll a lot of our own tests for it. And it's an extremely nervous experience to be developing your own tests for something like bias and racism. It's neither comfortable nor is it what should actually be happening. So I think that there's an opportunity for like the US or a coalition of countries to lead here, because whoever moves first with conviction will ultimately define the landscape on which all standards get developed, because standards will depend on these measures and auditing mechanisms. Any other questions? Great question. All right, one at the back.
Hello, it was a really good presentation. I was just wondering, so your picture of the AI researchers desperately trying to get off of the train tracks.
Yes.
I mean, is it because it's just really hard work to try to do this, like scientific melding, or is it just, actually, I guess my general question is, how hard is it to put those two different sort of methodologies together, right?
Yeah. I mean, I think a lot of the challenge is that AI for many years, people were just trying to get this stuff to work. Like it really didn't work for a really, really long time, and it's only recently that it has become, or at least this strand of AI, resource-intensive deep learning, has become so effective that it's actually being deployed widely into the economy. So places like universities have not been set up as well to do the kinds of interdisciplinary research that helps us work on this, nor do academic incentives necessarily like push you to this. I'd be really interested to hear Anima's thoughts on this, because it looks like you've got a point, and you're a professor at Caltech, so let us know what you think.
Sorry, I was just...
Yeah.
Can you repeat that again?
Well, I was saying I'd be interested to know your thoughts, because you're a professor at Caltech as well as NVIDIA. So how can we do more of this sort of socio-technical research, and what do we need to do to make more of it happen?
Yeah, I think the collaboration is so important, right? Like earlier I emphasized collaborating with social sciences professors, ethics professors, that's so important. So, I think computer scientists don't have an answer to everything, so we need to be looking outwards. And that was related to, in fact, the question I was going to ask. You brought up the Hubble telescope, which is a very amazing scientific endeavor. And so what would that look for AI, right? We can't have like one just centralized entity that would be the equivalent of Hubble. So, how do you visualize what Hubble would look like?
Yeah, so and I'll answer this question and also respond more to yours that you just asked, which is, like, let's take an example like a really large language model, like GPT-3 or the one that Microsoft or NVIDIA have developed. You can't just release that model as open source into the world. Probably loads of adverse things happen if you do that. It's very unpredictable. You need to figure out a way to make it accessible. And so I think an AI Hubble looks like experimental infrastructure that facilitates hosting really, really large resource-intensive models and providing an access regime to them and an ability to experiment on them. And I think that one of the challenges we have right now is just at Anthropic, the new company I work on, we've already trained some really, really, really large language models, and we're trying to figure out how do we make them externally accessible. But making them externally accessible is very expensive. You need a really good security team so that people don't steal the model. You need to come up with policies for access. You need to come up with a load of decisions that as a private sector company you can make, but you probably wouldn't like to be the only one making them. So I think some of this is about creating a shared system where we can figure out some of these really big questions together. And if such a system existed, I think all the private sector companies would have an incentive to rotate staff there or have secondments happen there, because you can build something that solves all of your problems, not all of them, but some of your problems for you in the future.
Jack, it's interesting, the slide you had about all the companies that sort of followed GPT-3. It seems like if you can get this, overarching thing that's trying to unravel some of the problems and biases and other governance issues with these, you still have a massive coordination problem because you have all these different countries. And so I was curious if you have any thoughts based on your experience at OECD or other places. Where do you think the most promising venue is for talking about the international coordination of this? And also how governments and companies can interact in trying to talk together about this. There's a lot going on here with either OECD or UK or various forms of technology alliances that Western countries are trying to put together. And I'm just curious if you see any particular venue as more promising than others at the moment.
Yeah, I'm going to say something a little controversial here, which is I think these venues do useful work, but they don't have the right incentive structure to guarantee this kind of work. And what I mean specifically by that is there's a French company called Hugging Face, which is a very prominent sort of natural language processing company. It is participating in a project called Big Science, which involves a French supercomputer that has allocated loads of resources to an interdisciplinary group of academics plus Hugging Face to train a big model on it and to collectively work on figuring out many of these problems. And I think that that's actually a really interesting example of where we could go in the future. So my belief is coordination starts with a big pile of resources, like a supercomputer, and an ability for people to jointly access it to do one thing together. And I think that we need to puzzle our way to getting, maybe it's OECD or GPI or maybe another institution to help foot the bill for this. Because if I, just to be really blunt, if I put like a giant supercomputer on the table and say like, this is heavily subsidized, who wants it? Everyone wants it, because it's a subsidized giant supercomputer. And so I think that we need to come up with some approach like that to sort of push this further.
Thanks, Jack. For this new institution that would sort of shepherd SeedAI, I'm curious what you think its incentives should be and how it should be able to incentivize cooperation or compliance with companies. Is this legal? Is it sort of like car safety, or are we going to J.D. Power, or is it like the American Medical Association?
I think that tests that can horribly embarrass you are very effective. And tests that can also show that you've made really good investments are very effective. You know, it's kind of like how Tesla built quite an interesting, quite good car business, and part of that was pursuing the highest possible safety ratings in a bunch of different tests, so it could show up really well. I think tests incentivize good behavior, and they help identify bad behavior. And if we're in a world where there's tons of different actors, all of them are deploying systems, then I think that coming up with like really hard regulation isn't going to work. The technology moves really, really, really quickly. But coming up with some body that's continuously monitoring, measuring, and testing these systems probably has a chance to both incentivize good behavior and also serves as something of like a bully pulpit to really embarrass and shame companies that are deploying things that sort of don't fit the goals that any society would have. I'm struck by, you know, not to pick on them, but I'm just going to name it as an example. Amazon deployed some facial recognition technology, and then Joy Buolamwini et al. At MIT and other places examined that technology for biases. And they found that it had disparate biases depending on the demographic race of the person in the picture. As a consequence, not only did Amazon change its algorithms and so that it could like show up better there, but IBM did as well, Microsoft did as well, because they all saw this happen and they were like, oh, well, that's extremely bad. We should not like show up badly here. And I think that was a really interesting example, but it took like Joy Buolamwini being willing to go to war with like a $1 trillion company to do that, which is not like something we should expect people to just voluntarily do all the time. So you need to come up with an institution that sort of guarantees you're continuously doing this. I also think it's in everyone's interest, because everyone wants to no one wants to deploy a bad system. They just deploy systems and then they try and make them better. But if you can create a way to incentivize everyone working on systems with better properties, you know, most people are nice. They want to do the right thing, and you just need to give them a way to do it. I think probably I've got time for one more question before lunch, so any final questions? Otherwise we can break. All right. Thanks very much, everyone.